Welcome to another video on my ESP32 connected to LED, right here, buzzer, 7-segment display, actually 7 LEDs, not connecting event microphone, connected to LCD, keypad, non-functioning, LDR right here, fischertechnik motor for controlled by pulse modulation, and servo motor also controlled pulse modulation. LCD, by the way, controlled by ANSI C, and the rest is controlled by GPI, general purpose input output. With one thing, that the LDR is connected to general purpose input only. And that is where I want to focus on, because I've from the start been focusing on programming using the ArduinoIDE with an ESP plugin, and for the last couple of videos I have been focusing on ESP IDF toolchain, ordinary C, which makes it a bit harder, because from the Arduino point of view a lot of things are being dealt with under the horizon. And last time I found out that while the LDR is functioning quite nicely within the Arduino IDE, using the IDF toolchain, it apparently didn't work that way. It still works, because analog electronics just doesn't give in that easy, but it's input only. And not only that, the port that it is connected to is an ADC, analog to digital converter. A resistor, as an LDR is, light dependent resistor, is analog. So it has to take some samples, and from the samples it takes general value, and that value is the value that you want to have. So that's one thing that I want to work on. And second, I want to see again if these motors are willing to work. I'm using the motors in two projects, and in neither project they want to work. Other thing on the ESP, it has GPI, it has ANSI C, it has CAN bus, analog to digital conversion, Wi-Fi, Bluetooth, and since I haven't used Wi-Fi, Bluetooth, etc., and CAN bus, those are yet to come. So without further things, let's go to the software and see how things work out. Alright, and this is then the software environment with Arduino IDE, webcam, well, it is webcam, but use it for this screencast, and other than that I have also the code and command line interface for IDF, and then this is complete code. Also, luckily it's working again, the oscilloscope camera. Well, it's a camera pointing to an oscilloscope, but it has to be connected properly. What I tried to do last time was getting this to work. And before I go on, I realized that I have to get ownership of the interface. So I first have to see which interface is connected, and that is 2. So now I can actually send things to the ESP. Quite, let's say, important to do anything. So let's not make flash yet, and these are a bit strange things, since I copied it straight from the GitHub example. Error unknown static constant. Let's go to line 39. I have to look this up. So delete, but I think this is better. And then the other error is default VREF in line 135, which is where exactly? I don't see the cursor anywhere. Oh, there. Right. Default VREF. That is something I apparently missed. Right. And then implicit declaration in 137, which is here. Implicit declaration. Alright, those are two things that I have to check before going on. Alright, two things. First of all, if I go to line 39, then a few changes were made, and let's make the empty line here. This was a definition, and also default VREF turned out to be a definition. So I had to place those with that. And next thing was then with print car file type. Well, that turned out to be another function. So I haven't checked it yet, so let's do that now. Number of samples undeclared. That is remarkable. It is declared right now. Right here. Number of samples. It is declared, and right at the start. So this is strange that it still doesn't do it. Or I would have to do it like this. Define number of samples. Okay, let's try it. And yes, that's understandable. This has to go. expression. Why? First of all, this is okay, warning, 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 error. This is a definition. This says that number of samples is equal to the number of 64. Oh wait, that's my mistake. No. Yeah, no semicolon. That works better. Warning, warning, warning. And there you go. So now I may get nice things out of the LDR. Let's run make flash. And that's it. Make monitor. And you already see on oscilloscope some stuff appearing. Roll. Oh wow. 1039. Right. So now if I put my finger on it like this, it should change. The only thing is, does it? Now I have to look at the purple line. Removing. Yeah, question is this real? Not quite sure. Only one thing that I do know is that the motors don't do one single thing. Something here, yes, and that's slow, but that's not what I want. I want pulse for channel 1. That's not pulse modulation. And if I change to, no, the other way around, 100, not making any sense. None whatsoever. So this is also number of samples, by the way, for the ADC unit. Yeah, analog to digital conversion. Oh wait, this is for the analog to digital conversion, and this is for the pulse modulation. Pulse modulation is 180 degrees. And when I started with this, it just was turning around and around and around. So if I change this, just go here, and I say I want to do it 90. What will happen then? Right, quit this, make and flash. See whatever happens. Right, time to make monitor. What happens? And most likely, well, nothing at all. One other thing is, look at the voltage. This probe, the blue one, is for the voltage. Voltage is 5 volts, so it should be somewhere along this line. Alright, let me do something else, which I've done in the past too. I am going to press reset, if you like. No, that doesn't help anything. This should be 3.3 volts along the line. And this motor isn't doing a thing. The red line is the voltage. This red line. So then I should have on, wait, which line is where? This is the red line. Alright, this is the pulse width modulation. This is red. No, this is orange. That is red. So red should be indeed in here. And this one should be in here. And then I'm talking about that connection. So this is not red, but this is orange, should be in orange. This with the green thing is red, should be in red, and that is this one. So I am going to take away, well, not, yeah, I'm going to take away this probe for now and put it not here, because then it goes out. That is not even close to because this is 5, 3 would be here on the top of my nail. This is 1 volt. So this is something that is not really good. And one other thing I noticed is that the main here isn't properly seated. Now it is. This should be properly seated as well, but it looks like it is. No, it's 0. Absolutely 0. I think I found a problem in the wiring. Why the motors don't work anymore. I'll have to check that out. Alright, and take a look now at the oscilloscope. 3.3 volts. The wire was completely gone. And when I connected it to the motor, this motor immediately started working. This one did not, but this one sure did. So let me disconnect this part, or this part again. Well, anyway, it did work. It did get one boost. How to make sure that I don't ruin things? Let me disconnect this one, this wire, because that's the voltage to the motor, and reconnect. Right. Now I have this one anyway. Let me. Okay, that's doing 3.3 volts approximately. But that doesn't mean anything right now. Let me reconnect this one to the LED again, because I still don't have pulse width modulation here. And considering the place this is, I should have pulse width modulation. Let's take another one. That is the orange wire right here. Alright, I have to change it. Ah, there goes the motor. That is one thing. So now I have LDR working, I have a motor working, and I have LED and 7-segment display working. Not LCD yet. So the problem in this experiment with the servo motor has been solved by a loose wire, fixing a loose wire, but that still does not explain this one. Because that one is still non-functioning as far as I'm concerned. So whatever that is, I am not sure at all. And this LDR can go because it obviously has no meaning. Go. And still it doesn't always work, the motor, and the fischertechnik motor doesn't work at all right now. It doesn't even tremble, it doesn't do anything. Nothing, and this one doesn't feel like doing anything at all either. Moving back the probe. You see here a change in signal, but it should be something like that. And it has a sleep for 1 second. If I take this and I put this another way later on, let's do that. So oh, I can't select, of course, because it's VI. So 1, 2, 3, 4, 5, 6, 7. 7 lines to be copied. And I'm going to do that right there. Then from 90 down to 1. That would be a nice one. Down to, yeah, so replace, and down to 0. And this, of course, minus, minus. And then pulse modulation down. Right. Let's do that one. Interrupt. Make. Alright. Make flash. And see how that works out. Right, and then make monitor to start everything. And now I should actually get the motor in two ways. Question is, will that happen? In signal, it's not happen. It's not happening at all. No, I'm disappointed in that one. At least the voltage is correct, but this doesn't make any sense. So, in that aspect, I am quitting this, going to here. This is all set yet. Let's see if this makes a slight difference. Go. And there goes the fischertechnik motor. LCD goes. LED, sensor segment display, and this will be the time to start the servo motor. And here you see, okay, that's the buzzer. Now I have again this weird thing of the pulse modulation, but the servo motor doesn't do a thing. Only the fischertechnik motor does, while with the IDF it was the reverse, it was that other thing that did. So let's say a bit confusing. But this proves that everything does work, material wise speaking. And that's what I end with right now. So with a few contradicting results, and now you can see both motors working for a little moment. So yes, it does work. Well, thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. You can also follow me via Instagram and Twitter. Please show your support by making a donation via either PayPal or Wired. And You can also become a patron and depending on the pledge you make, may have your name mentioned. More information or all information under this video, website, Patreon page, social media, and on my website much more information. This is going to be continued. Have a nice day and bye bye.